These are algebra notes for section 2.4, where we are going to use algebraic function notation. So there's two different types of problems we're going to look at. We can solve it when the input is specified. So that's whenever we know the number we're going to use for x or whatever the input is. So we'll put, this one says f of 2. So we're going to put 2 in where we see an x, and then solve for the output, generating the ordered pair. Now, sometimes we're going to have to solve when the output is specified, so that's when we're solving for x. This is, let's see, I would say you're going to do both. In this section, we're going to use these three equations, f of x, g of x, whoops, I wanted to make that a different color, g of x, and h of x. We're going to use these equations a couple different times in these notes. So in this box of examples, we're going to be given the input value. So f of -2 says to put -2 into that f equation. That's our yellow one because each of them has a different letter. So f of -2 says -4 times -2, add 7. -4 times -2 is 8. 8 plus 7 is 15. So the ordered pair was an input of -2 and an output of 15. H of -2 is the blue equation. So -8 plus 6 times -2 minus -2 squared. Whoops. So -8 plus 6 times -2. So that's going to be plus -12. I'm just going to write -12 because I don't like double signs. And then we're subtracting. And when we evaluate -2 squared, -2 squared is -2 times -2, which equals +4. So we're subtracting that 4. And as we move across this problem, -8 take away 12 is -20, minus 4 more, -24. So my input was -2 to get the output -24. Number 3 is g of 5. So that's the green equation. G of 5 is 2 to the 5th. We're going to make this 5 over 1 since it's getting multiplied by a fraction. And my fraction work, 2 over 5 times 5 over 1. You could do 10 over 5 is 2. So 2 minus 9 equals -7. So 5, -7. Then we have f of 7, so that's the yellow equation. f7 equals -4 times 7 plus 7. So -28 plus 7, -21. So my input was 7, my output was -21. Okay, now we're going to use these again, and we're doing an extra step. So in this one, we're going to take the first example, we're going to take g of 6, and then we also have to take h of 1, and then we're going to add them together. So you're going to solve them separately. So g of 6, we're going to plug 6 into that equation. So 2/5 times 6 over 1 minus 9. Now I know what you're thinking. 2/5 times 6 over 1. It's going to give me a fraction of 12/5. So 12/5 minus 9. And 12/5, this is one of those times where I would be okay with you using a decimal. 12/5 is 2 2/5, so that's 2.4 minus 9. So that is 2.4 minus 9. That's negative 6.6. Now, we're going to do the second part, and we're going to plug 1 in for h. Okay, so not for h, but into the h equation. So the h of 1 is negative 8 plus 6 times 1 minus 1 squared. So negative 8 plus 6 and minus 1, because 1 squared is 1. So negative 8 plus 6 is negative 2. Negative 2 take away 1 is negative 3. And when we add those two together, negative 6.6 plus negative 3, so negative 6.6, when you add a negative, you subtract, that's negative 9.6 as my final answer. Same process over here. We're going to use two separate functions with two different inputs. We'll get two different outputs, and then we're going to add them together. Now, you could subtract them, you could multiply them. It just depends on what the problem you're being given. These two just both happen to be add. So f of 4, f of negative 4 would be negative 4 times negative 4, then add 7, 16 plus 7, f of negative 4 is 23. And then we've got h of 8, so negative 8 plus 6 times 8 minus 8 squared. So negative 8, 6 times 8 is 48, then minus 64. And when we add, going left to right, negative 8 plus 48 is 40, then minus 64, that's going to equal negative 24. And our last step is to add those two outputs together. So 23 plus negative 24 turns into 23 minus 24, which is negative 1 as my final answer. Okay, in this section, we're given the output. So I don't know the input, so I'm going to solve for the input. Again, we're still using these three different equations, or different functions, I should say. And for this first one, what is x when f of x equals 31? So f of x equals negative 4x plus 7. And we want f of x to equal 31. So 31 equals negative 4x plus 7. So we don't know x. We're going to find out what it is. We're going to subtract the 7 first on each side. 31 minus 7 is 24. That equals negative 4x. And when we isolate x, we'll divide both sides by negative 4. So x equals negative 6. So my input is negative 6, and that gave me the output of 31. So I was given an output. Okay. Next, what is x when g of x equals 21? So my g of x equation is 2/5 x minus 9. And I'm saying that g of x is equal to 21. So I'll put a 21 where I see g of x. And that's 2/5 x minus 9. So my first step is to add 9. So 30, I'm going to make 30 over 1 because I know I'm working with a fraction of 2/5. And then instead of dividing both sides by 2/5, I'm going to multiply by its reciprocal, 5 over 2. Now 5 and 5 cancel, 2 and 2 cancel. And when you do your fraction work, you can do 5 times 30 is 150 divided by 2, which is 75, and that's what x is equal to. The other way to do that work is to have 5 over 2 times 30 over 1. And you can cross cancel. You can say, okay, 2 and 30 will have common factors. The greatest common factor is 2. So 2 goes into 2 one time. And 30 goes into 2 15 times. And then you can do 5 times 15 over 1. So 75 over 1. Either way you get there. We want your input to be 75 and your output to be 21. Okay, in this last section, we're still using these same 3 functions. We're going to take 5, plug it into the f of x function, and see if it gets generates an output of 27. So f of 5 equals negative 4 times 5 plus 7. Negative 4 times 5 is negative 20. Add 7. That makes negative 13. Does it equal 27? No, so it's not a solution. G of 10, so we're going to take 2/5 of 10 over 1. Well, 1/5 of 10 is 2. 2/5 of it would be 4. You could also multiply it like this. 2/5 times 10 over 1. 20 over 5 would equal 4. So 4 minus 9, does that equal negative 5? And it does, so yes. It is a solution. That means it would be on that graphed line. Now, is h of 0, does that equal negative 8? So h of 0 is negative 8 plus 6 times 0 minus 0 squared. So 0 is a really easy input. So negative 8 plus 0 and minus 0, that's just negative 8. And it was asking if we plug in 0, will we get a negative 8? Yes. It is a solution. In our last one, we're using the yellow equation one more time. F of negative 1 equals negative 4, where I see my x, I'm substituting negative 1 and adding 7. So that will be 4 plus 7. That's 11. Is that a solution? We wanted it to be 3, so this is not a solution.